All right, welcome to our lesson for today, where we're going to be working with fractions, specifically adding mixed numbers. So let's take a look at a quick review of what a mixed number is, because that's going to be an important thing to have fresh on our minds today. A mixed number is a fraction that has a whole part and then it has a fractional part together. So, for example, I've got this picture of some pizza. You can see here that there are two whole pizzas that have been cut into four slices each. And we've talked a little bit about this over the last couple of lessons, but our denominator is the number of parts that make one whole of something. So in this case, the pizzas are in four slices each, and those two whole pizzas have not been touched yet. No one's eaten any slices. However, there is an extra slice out here that is not a part of a whole pizza anymore. It's just the part. So this is our fractional part, and this is our whole number part. So you can see here it's written two whole pizzas and 1/4 of a pizza. So that's a mixed number, a whole part and a fractional part. Let's quickly review one last thing. These are adding fractions with like denominators. This is going to be a key step as you are solving mixed numbers being added together. We're going to continue using the same strategies that we have, where we look for common or like denominators as well as related denominators. That's still going to be an essential part. So just as a quick review, anytime we have a fraction plus another fraction, and they have like denominators, that means that the denominators are the same, all we need to do is add straight across the top and keep the denominator the same. So in this case, we would do 7 plus 11 is 18 for our numerator, and our denominator does not change because the number of parts in the whole did not change. It still is 12 parts in the whole. And that would be our improper fraction, but when we are writing our answers in simplified form, which we always need to do, we need to change this into a mixed number. So we're going to ask, this is another way of writing 18 divided by 12. So we'll ask ourselves, what is 18 divided by 12? 12 goes into 18 one whole time. 12 times 1 is 12. Subtract to find the difference, and that leaves us with 6. And if you remember, we can just take that remainder and make it our numerator, the fractional part of our mixed number. And then we keep this denominator. You can see it's the same thing. We just brought it over here. This is another place to write the denominator. We just keep that the same. This needs to be simplified further. It would be 1 and 1/2 because 6 is half of 12. So that's just a quick review. Whenever we've got our common denominator or our like denominator, we are good to go, just adding straight across the top. We're going to continue using that strategy today. Let's take a look here at, I've got a little picture, a little diagram here representing what we see written in this problem here. 3 1/3 plus 4 1/5. Now there's a couple things that are a little different from our last lesson. So I'd like you to tell me, what do you notice is different or similar? And what do you think changes from this first row here, following this arrow, to this second row? What changes? What is happening here in this picture? Awesome. Thank you for sharing your thoughts on what you notice. Now let's take a look together and let's dive in deep. Let's see how what you noticed applies to our thinking today, and how you can take what you noticed and use it as you work on today's assignment. So here we go. I've kept this picture up here for our reference, and I'm seeing here, okay, my first fraction is 3 1/3. That's a mixed number, so that means this is a whole part and this is a fractional part, right? So let's look at our picture and let's see. I see right here 1 whole, 2, 3 wholes. Well, that's a crazy 3 right there. That's okay. My pen is a little crazy. So there's my wholes, my fractional part, or I'm sorry, my whole part. And my fractional part I can see is represented right here. Now these dotted lines, these are showing us that when we find a common denominator, we're going to need to break this into more parts. We talked about that in our last lesson. So you can see here the dark lines, they're showing 1/3 right here. There's that fractional part. But then these little dotted lines are going to come in a little later when we find that common denominator, because that's like not the actual number of parts in the whole, but we have broken it further to find the same number of parts for each whole. So, okay, there's my 3 1/3, and now let's get another color here. Let's look at the 4/5. So here, let's pay attention to those dark lines, not the dotted lines. I'll try to mark those up right there. So you can see there are fifths. That's our denominator. And it's been broken into it's been shaded into 1, 2, 3, 4 parts. So 4 out of those 5 parts are shaded in. And again, those dotted lines are matching up with what we see over here on this circle where we originally had thirds. We've broken it into smaller parts because we don't have a common denominator here. So as we follow this arrow down to the second row, I'm noticing that it looks like we've combined both of these fractional parts. The whole stayed the same. We still have 1, 2, 3 wholes. But once we've combined these fractional parts, I'm seeing it was enough to make another whole when we added them together. And we still had a little bit left over. That's our fractional part. So I'm thinking that as we add these fractions together, 3 1/3 plus 4/5, we're going to end up with more than 3 wholes. We're going to actually have 4 wholes and a little bit left over here. So based on my picture, it looks like I have 4 whole circles. And let's see how much I've got here in my fractional part. 1, 2 parts out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it looks like that's what our common denominator was. So our answer to this equation, 3 1/3 plus 4/5, is 4 2/15. Let's break this down and see how we can use the standard algorithm for adding fractions to get this answer, because we're not going to always have a picture to follow along and break apart. And we're also not going to always want to draw a picture because, good grief, that takes forever. So let's look at how we can solve this using just math, just using the standard algorithm. So we know when we add numbers together, like let's say I'm just going to add 45 plus 23, the standard algorithm has us line up our values. We've got our ones place, our tens place, and then we just add straight down, right? We can do a very similar thing with fractions, including fractions with mixed numbers. So whenever I'm adding mixed numbers, or at least one mixed number to one proper fraction, I like to stack the values. So I put my whole part and my fractional part, 3 1/3, plus, now there's not a whole part for 4/5. However, in upcoming lessons, we will be adding with another whole. So you can leave that blank for now and just write the fractional part under the other fractional part. So you can see I've got 3 1/3 plus 4/5. This helps me keep track of what I'm supposed to be adding together. Now I come over, I'm going to change my color a little bit here, and I want to find a common denominator. I want to rewrite these fractions as fractions that have the same number of parts, or they're equivalent fractions. We're not changing the value. As you can still see, this is still 1/3, but we just changed the name. We gave it a new denominator. So what I like to do is focus on the fractional part first. So finding that common denominator means finding the lowest common denominator, the lowest number that both 3 and 5 can go into. And because I know that 3 times 5 is 15, and that there's no other smaller numbers that 3 and 5 go into, I know that 15 is going to be my lowest common denominator. Again, not giving it a new value, just writing an equivalent fraction. So what did I do? I multiplied 5 times 3 to get 15, and whatever I do to the bottom, I'm going to do to the top. So that gives me 4 times 3 is 12 in my numerator of my equivalent fraction. And up here, I said, well, 3 times what is 15? Well, I multiplied that by 5. So I'll multiply the top by 5 as well. And that gives me 1 times 5, which is 5. So now my fractional parts have equivalent, or are written as equivalent fractions with a new denominator that is a common denominator. So all I need to do now is add my fractional parts and then add in my whole. So I am adding 5/15 plus 12/15. That gives me 17/15, which, if we look at our picture up here again, I can see here's 15/15, 16, 17/15. So that's matching our picture so far. That's pretty good. Now, what we need to do is we need to add 3 plus 17/15, because we need to make sure that we don't forget about this whole part that was still in there. Now, there's a couple ways that we can go about this. I think my favorite is to write this fractional part as a mixed number and then add any wholes together. So let's see what that looks like. We know that this is another way of writing 17 divided by 5, right? So let's write that out. 17 divided by 5. Oh, I'm sorry, divided by 15. 15 goes into 17 one whole time. 1 times 15 is just 15. Let's subtract to find the difference. And I apologize, I'm running out of space here. I'm going to write my fractional part right here. 2/15. So that means we're adding 3 plus 1 and 2/15. All I need to do is add my wholes together. And that's going to give me 4, because 3 plus 1 is 4, and 2/15. There's my final answer. And that's exactly what we got from looking at that picture, right? You might be looking at this and thinking, whoa, that was a lot of steps. And there are a fair amount of steps here, but each step is an important one. So let's go over what we did. We found, we rewrote our equation as a standard algorithm. We stacked the parts, whole over whole, fraction over fraction. Then we had to find a common denominator of the fractional parts and rewrote the equivalent fraction with a common denominator. From there, all we had to do was simply add across the top. We turned this into a mixed number, and we added that mixed number to our whole part. In the end, that gave us 4 and 2/15. Let's take a look at another one, because practice is going to be what makes us better at this. Here I'm seeing that we have 4/5 plus 1 and 7/10. Take a look at the picture. Pay attention to those, not the dotted lines, but the solid lines. Breaking this into fifths. And I want you to think about, what do you notice? And what do you think is happening as we're adding these together? Thanks for sharing your thoughts. Let's solve together. And I'm not going to talk too much about the picture part. Instead, I'm going to focus on our standard algorithm. So we are adding 4/5 plus 1 and 7/10. So I'm just going to put my whole on top just because I like that better. Helps me stay more organized. So I have 1 and 7/10 plus 4/5. And we know that 1 and 7/10 is kind of like saying 1 plus 7/10. So let's take a look here. I don't have a common denominator because 5 and 10 are not the same. However, I do have related denominators, which is great news, because if they're related, all we need to do is keep this fraction the same and then change this one to an equivalent fraction with the same denominator, because 5 goes into 10 evenly. So in this case, we don't need to do anything to this 7/10. We get to just keep it the same. But down here, we do need to do a little bit of multiplication to get that common denominator of 10. We want it to be 10. So 5 times what is 10? It's 2. 5 times 2. Whatever we do to the bottom, we'll do to the top as well. 4 times 2 is 8. So now I've got my equivalent fraction parts. Let's add those fractional parts together. 7/10 plus 8/10. Adding straight across the top, that gives us 15. We keep the denominator the same, 15/10. Now that we've got our fractional parts added, let's add that to our whole. So we're going to write this down. We're going to say 1 whole plus 15/10. Let's make 15/10 into into a mixed number so that we can add the wholes together. Here we go. 15 divided by 10. Let's write it up here. 10 goes into 15 one whole time. Subtract to find the difference. The remainder becomes our numerator, and we keep the denominator the same. And right away, I'm thinking, well, 5 is half of 10, so I can automatically simplify this and write it as 1.5. So, because 15/10 is equal to 1.5, I'm really just adding 1 whole, because we need to make sure we don't forget that, plus our 1.5. 1 plus 1 whole is 2 wholes, and we keep that fractional part left over, and our answer is 1, 2.5, just like our picture shows, 2.5. Let's do another one. Practice makes perfect. All right, standard algorithm time. This time, no picture. Now we're just using our standard algorithm. We're going to stack our fractions. Whole over whole, fraction part over fraction part. And these are not common denominators. 4 and 10, not the same. So are they related? No, 4 does not go into 10 evenly, so we're going to have to use multiplication to write an equivalent fraction. So I'm going to come over here and write my equal signs. I'm going to have to use some multiplication here. What's the lowest common denominator for 4 and 10? The smallest number that both numbers can go into evenly. Let's think through the multiples of 10 and see if we can find one that 4 also goes into. So 10 is the first multiple, 4 does not go in. 20 is the second multiple, and 4 does go into 20 because I know that 4 times 5 is 20. So our common denominator is going to be 20. Let's multiply. So 10 times 2 is what we had to do to get 20. So we're going to do 3 times 2 to get our numerator. There's our equivalent fraction. 4 times what is 20? 4 times 5 is 20. So now we just do the same to the top, which gives us an equivalent fraction of 15/20. Now we can simply add those numerators across the top to get our fractional part. So we've got 15/20 plus 6/20, and that gives us 21/20. Cool. Now we can wait to make this into a mixed number, or we can do it now because we know we need to do it eventually because we're going to add that into our whole. So I'm just going to do it now. I'm going to say, okay, 21 divided by 20. 20 goes in one whole time. Subtract to find the difference. And that leaves me with 1 and 1/20. So there's my fraction and whole. So we're going to add that in with our 8 that we started with. So 8 wholes plus 1 and 1/20. Adding the wholes together, 8 plus 1 is 9. And our fraction part does not change. So our answer is 9 and 1/20. All right. Let's do one last one together. For this one, I see that we are adding 3/9 plus 4.5. Let's get the standard algorithm and stack whole over whole, fraction over fraction. 4.5 plus 3/9. All right, let's check our denominators. Are they like? 2 and 9 are not the same? No. Are they related? 2 does not go into 9 evenly, sadly, so we're going to need to use multiplication on both fractions to find a common denominator. So we're going to use multiplication all the way across the board. Let's think of the lowest common denominator that both 2 and 9 can go into evenly. Let's think about the multiples of 9 and see if 2 can go into any of them. 1 times 9 is 9, so nope, that won't work. 2 times 9 is 18. That's the next lowest multiple. And 2 goes into it because we know 2 times 9 is 18 and 9 times 2 is 18. So 18 is going to be our common denominator. What did we multiply 9 by to get 18? 2. So we'll do the same thing to the numerator there. That gives us 6/18. What did we multiply 2 by to get to 18? We multiplied it by 9. So we'll do the same thing to our numerator, which gives us 9/18. Let's add those fractional parts together. 9/18 plus 6/18. 6 plus 9 is 15. Keep the denominator the same. 15/18. Now for this one, 15 is less than 18. So it is not an improper fraction. That's actually a proper fraction. The only thing about it is that we can simplify it further. So let's go ahead and simplify that now. So looking for a number that goes into both 15 and 18, common factor. I know that 3 goes into both. So let's divide by 3 to simplify. 15 divided by 3 is 5. And 18 divided by 3 is 6. So the simplified form is 5/6 for our fraction part. Then we just need to add in our whole now. So 4 plus 5/6 equals 4 and 5/6. And there's our final answer. So let's quickly review and reflect. What were the main mathematical concepts or ideas you learned today? So think about what was the main idea? What was the title of this lesson? What was the main thing you learned that you took away? And finally, what do you think will be important to remember as you do the homework or the assignment today? What key tips, tricks, and steps should you follow in order to make sure that you will be successful on the questions you answer on your own today? Thank you for sharing your thoughts. If you have any questions or you need some help, please reach out to your teacher. In the meantime, goodbye for now.